We will begin with the first example that says 2 upon x plus 5 upon y minus 7 upon z. One thing you will notice with this set of fractions is that there is no common denominator. So how do we achieve that? Well, the lowest common multiple strategy will help us in this case. And obviously, since we don't know what x, y, or z stands for, what we can do is to multiply the three letters together to create the lowest common multiple. Therefore, we begin by working out the lowest common multiple. The lowest common multiple of x, y, and z is x, y, z. So this is what we are going to be operating with as our denominator. So to do that, we create our LCM right below here as x, y, and z, and then use it to work out the other fractions and the numerator. So we begin by first dividing x, y, z by x. That obviously is going to give us y, z. So we'll be multiplying the y, z by the numerator 2. That is 2 multiplying y, z. The first part is done. Plus, we come to divide x, y, z by y. That leaves us with xz. So we'll be multiplying xz by the 5 at the numerator. So this is going to be 5 multiplying x and z. Minus z comes to divide xyz, leaves us with xy. So we'll be multiplying 7 with xy. Now as you see here, 2 multiply yz will leave us with 2yz. And 5 multiply xz leaves us with 5xz. While negative 7 multiplying xy leaves us with negative 7xy. And the numerator remains common, which is xyz. We have ended up leaving our fraction in a single form. So this is the answer to this question we have just solved for number 1. It is as simple as that. We would have simplified the numerator if all the letters we have here, the variables, if they were all the same. But this time you can see that they are not like them, so we cannot simplify any further. Let us take example 2. Example 2 has 1 upon x minus 7 minus 2 upon x plus 1 plus 3 upon x minus 2. We are going to apply the same strategy of common denominator to work things out, and in that case the LCM will help us to do that. So to approach this problem, I'll begin first by writing out the LCM of the denominators. The denominators are 7 minus, the denominators are x minus 7, x plus 1, and x minus 2. Their LCM is simply multiplying 3 of them together. So the LCM is x minus 7, x add 1, and x minus 2. They will form my denominator, so I'll be working with them the way they are. Let us proceed and see how we can also apply the same method just like we solved in question 1. So to begin, I'll bring x minus 7 on the first denominator to divide the LCM. That leaves me with x plus 1 and x minus 2. So I'll be multiplying that by 1, and that leaves me with the same thing. So x plus 1 and x minus 2 remain. Minus, this time x plus 1 divides the denominator. We are left with x minus 7 and x minus 2. That will be multiplying the numerator of 2. So I'll just write it down here. 2 will be multiplying x minus 7 and x minus 2. Done. The next case is to come to divide the same denominator again by x minus 2. In that case, x minus 2 cancels out x minus 2. And we are left with x minus 7 and x plus 1, which will be multiplied by the 3 at the numerator. So plus 3, which is at the numerator, multiplying x minus 7 and x plus 1. Now this is done, but we can't end it that way. We can try now to open up the brackets. When we open up the brackets, you will get to notice that there will be so many like terms at the numerator especially, which we can easily cancel out. So let's work it out. So to do that, we open up the bracket. X multiplies x will give us x squared. And then x multiplies 2 gives us minus 2x. And then 1 multiply x will give us plus 1x. And 1 multiply 2 will give us minus 2. That's done for the first case. Minus. Before I use 2 to multiply, I should simplify the brackets first. So x multiplies x will give me x squared. And then x multiplies negative 2 will give me negative 2x. Then negative 7 multiplies x gives me negative 7x, and negative 7 multiplies negative 2 will give me positive 14. Close that down. Then we'll go forward to opening up the next brackets. This time x multiplies x will give me x squared. Next, x multiplies 1 will give me 1x. I'll just write it as x positive this time. Now negative 7 multiplies x will give me negative 7x. And negative 7 multiplies positive 1 will give me negative 7. The numerator is also done for this case. I will leave the denominator the same way it has been. So the denominator, I don't want to open it up yet. Let me finish up with the numerator. X minus 7 denominator, open bracket, x add 1, and then open another bracket, x minus 2. This is where we have reached so far. Remember I told you when you open up the brackets entirely, you will be able to simplify. So to do that, it is time to use the constants like negative 2 to open up the brackets, and also find a way to simplify what's inside the bracket to make it smaller. So we'll do that at the next stage, which is right now. For the first bracket, we can easily write down our x squared since it is the only one in there, but negative 2x add x will give us negative 1x. So we'll write it as negative x minus 2. This is done. To open up this bracket, I can simplify it first, yeah? So first, negative 2 multiplies x squared will leave me with negative 2x squared. That's it. But before I go in here, watch. This is negative 2x minus 7x, which is obviously negative 9x. Yeah? Now, with this negative 9x, I'll be multiplying it with negative 2, and that's going to give me positive 18x. That's done. Right here, we have 14 constant, positive. So, negative 2 multiplies 14 will give us negative 28. We're done with that bracket. Let's go forward to the next. Here we are multiplying everything by positive 3. First, there is only one variable bearing the squared. Therefore, we just multiply it directly. 3 add x squared will give us 3x squared. And then watch inside. We have x minus 7x. That will give us negative 6x. Negative 6x. Multiply the negative 6x by the 3 outside the bracket. That gives you negative 18x. Done, yeah? And the next one is multiply 3 by 7. That is negative 7. So multiply 3 by negative 7. That leaves you with negative 21. So we have ended up opening up all the brackets at the numerator. We are ready now to simplify. But let's write down our denominator. The denominator remains the same. I don't want to open up the brackets yet. You will see my reasons later. Open bracket, x add 1. Open another bracket, x minus 2. Okay. Now at this stage, we can simplify the numerator. So to do that, we just create a space here. To simplify the numerator, all we need to do is more like collecting the like terms together and working them out. And so we will look out for the squares. First we have 1x squared here. There is minus 2x squared and there is plus 3x squared. Let's work it out. X squared minus 2x squared leaves us with negative 1x squared. Negative 1x squared add 3x squared is the same thing as 3x squared minus 1x squared, which is the same as 2x squared. So we write it down here, 2x squared. We're done with the x squares. The next one we're going to look at is the x term. Here we have the negative x term. We can just circle it or we can use another star. Let's use a star to represent this one. And then the x term is also here. The next x term is here. First, watch something. This is positive 18x. This is negative 18x. Both of them can cancel each other out so that only negative x will be the x variable remaining. Negative x. Done. Now it's time for the constant. Negative 2 minus 28 will give you negative 30. Negative 30 minus 21 will give us negative 51. So we just write it up here, negative or minus 51 right here. The denominator remains the same, which is x minus 7, open another bracket, x add 1, and open the last bracket, x minus 2. Now at this stage, the numerator is a quadratic equation, leaving 2x squared minus x minus 51. We can think of a method to see if it's possible for us to simplify, maybe by factorization, but this is not factorizable. And because it is not factorizable, there is nothing at the numerator that we can use to cancel out something at the denominator. Therefore, this becomes our final answer. There is no need stressing yourself on the denominator when you know that nothing is going to change since you cannot factorize the numerator. Hence, this becomes our final answer for question 2. Question 3 says 12x squared y squared minus 8xy cubed is all over 18x cubed y minus 8xy cubed. We need to simplify this fraction and leave it as a single fraction. Now watch, at the numerator you notice that there are some common factors. The same thing you will notice at the denominator. Therefore, we need to be very careful as we factorize. So the very first thing I'm going to do as part of my solution is to factorize both the numerator and the denominator. Factorize both numerator, I'll just write it as NUM, and denominator. That is the very first thing I'm going to do. Alright, to do that now, we apply our basic skill of highest common factors. That is what we will use to work here. Now, the common factor between 12 and 8 is 4. Because 4 can divide both of them. That's the highest common factor they have. The highest common factor between x squared and x is x. And the highest common factor between y squared and y cubed is y squared. This is the highest common factor with which we will create the new expression at the numerator. So, to get 12, 4 multiplies 3. To get x squared, x has to multiply x. And to get y squared can only multiply 1, which is invisibly standing behind the x. No need to write another one there. So put your minus sign. To get 8, 4 needs to multiply 2. To get x outside needs to multiply 1. There's no need writing the 1, it's already invisibly there. So to get y cubed, y squared will need to multiply y. Close the bracket. And then the numerator is done. Let's go to the denominator and do the same factorization. The highest common factor between 18 and 8 is the number 2. So, what is the highest common factor between x cubed and x? That is x. What about y and y cubed? That is y. This is our highest common factor for the denominator. So right now, to get 18, 2 has to multiply the number 9. Let me write that better. 9, okay? To get x cubed, the letter x needs to multiply x squared. And to get y needs to multiply just 1, which we don't need to write. It's already there invisibly. Minus sign comes in. To get 8, 2 needs to multiply 4. Then to get x needs to multiply 1 invisibly. To get y cubed, y outside needs to multiply y squared. We are also done with this stage of factorizing. Now the next thing we need to do right now is to simplify. And to do that, watch, there are some things we can factor out or cancel out between the numerator and the denominator, which you can see here. 2 at the denominator can cancel out 4 at the numerator, leaving us with 2. And the x at the denominator can easily cancel out the x at the numerator. For the y at the denominator can cancel out the y at the numerator, leaving us with y. So we are left on the numerator with 2y, open a bracket, 3x minus 2y. This is what we are left with on the numerator. But at the denominator, we have 9x squared minus 4y squared. Now there is still something we can do. A good look at the denominator shows you some kind of difference of two squares. So we have to simplify that because it will help us see if there is anything common again between the denominator and the numerator. So to do that, we just continue here, writing down our numerator back, 2y open bracket 3x minus 2y close the bracket. At the denominator, 9x squared can be represented with 3x close the bracket, both of them squared, because 3 squared is 9 and x squared is x squared. That's it. Minus 4y squared can also be written as 2y close the bracket squared, because 2 squared gives us 4 and y squared is already represented here as y squared. At this juncture, you notice difference of two squares existing. Therefore, we have to demonstrate the expansion scale to be able to simplify the denominator. So let's do that right away. At the numerator, we have 2y, open a bracket, 3x minus 2y inside the bracket. Close your bracket. At the denominator, it is time for us now to demonstrate our scale of difference of two squares, which is done like this. 3x minus 2y in one bracket multiplies 3x add 2y in yet another bracket. We have just expanded the difference of two squares that we have at the denominator. Now, at this level, you can compare the numerator and the denominator and notice that something is common. 3x minus 2y is common between the numerator and the denominator, which means that we can comfortably cancel them out. Therefore, for the numerator, we just have 2y. But for the denominator, we have just 3x add 2y. It is as easy as that. In case you want to understand this much better, I will advise you to pause the video each time a question is going to be solved. Try working it out by yourself to demonstrate whether you know it or not. After that, you can unpause it and see the methods I have applied. I believe that will help you. Thanks a lot for watching.